So, I mean, the basic rule is, you have to multiply by A inverse on the left so that it cancels with this A that's on the left. That's correct. So, and, in our usual way of dealing with matrices, where the vectors are column vectors, I mean, it's just something to remember that if you have a square matrix times a column vector, I mean, the product that makes sense is with the matrix on the left, the vector on the right. The other one just doesn't work. It's not sized. You cannot take x times A if A and x, if A is a square matrix and x is a column vector, this product makes sense. The other one doesn't make sense. It's not the right size. Okay. So what we need to do is to learn how to invert a matrix. And it's useful to know first for your general knowledge, and second because actually it's actually useful later for things we'll see in this class. So in particular on the exam, you will need to know how to invert a matrix by hand. So I should say this formula is actually good for small matrices, 3 by 3, 4 by 4. It's not good at all if you have a matrix of size 1,000 by 1,000. So in computer software, actually for small matrices, they do this. For larger matrices, they use other algorithms. But let's just see how we do it. So I'm going to do it. Okay, so first of all, I will give you the final answer. And of course, for that, I will need to explain what the answer means. So we'll have to compute something called the adjoint matrix. And I will tell you how to do that. And then we'll divide by the determinant of A. So how do we get to the adjoint matrix? So let's go through the steps on a 3 by 3 example. The steps are the same no matter what the size is, but let's do 3 by 3. So let's say that I'm giving you the matrix A. Well, let's say it's the same as earlier, the one that I erased. So that was the one relating our x's and our u's. So the first thing I want to do is find what's called the minors. So what's a minor? Well, it's a slightly smaller determinant. We've already seen them without calling them that way. So, for example, so the matrix of minors will have again the same size. Okay? Let's say we want this entry. Then we just delete this row and this column. Sorry, this row and this column, and we're left with a 2 by 2 determinant. Okay? So here we'll put the determinant 4, 5, 1, 2, which is 4 times 2, 8, minus 5, 3. Let's do the next one. So for this entry, I delete this row and this column. I'm left with 2, 5, 1, 2. Determinant will be 2 times 2 minus 5 is negative 1. Then minus 2. Then I get to the second row. So I get to this entry. Well, to find the minor here, I will delete this row and this column, and I'm left with 3, 3, 1, 2. 3 times 2 minus 3 is 3. And let me just cheat and give you the others. I mean, I think I've shown you that I can do them, okay? So let's just explain the last one again. The last one, this 2, so to find the minor here, I delete this column and this row, and I take this determinant, 2 times 4 minus 2 times 3. Okay, so it's the same kind of manipulation that we've seen when we've taken determinants and cross products. Okay, step 2, we go to another matrix that's called cofactors. So the cofactors are pretty much the same thing as the minors, except the signs are slightly different. Okay, so what we do is we flip signs according to a checkerboard diagram. So you start with a plus in the upper left corner, and you alternate pluses and minuses. Okay, so the rule is if there's a plus somewhere, then there's a minus next to it and below it. And then below a minus or to the right of a minus, there's a plus. Okay, so that's what it looks in size 3 by 3. So what do I mean by that? So I don't mean, make this positive, make this negative, and so on. That's not what I mean. What I mean is, if there's a plus, that means leave it alone. Okay? We don't do anything to it. If there's a minus, that means we flip the sign. Okay, so here we get, 3, then 1, minus 2, minus 3, 1, plus 1. Maybe I'll put pluses just to emphasize. 3, minus 4, and 2. Okay? That step is pretty easy. I mean, the only hard step in terms of calculations is this one, because you have to compute all of these 2 by 2 determinants. By the way, I mean, this minus sign here, see, it's actually very related to the way in which, when we do a cross product, we have a minus sign for the second entry. Okay, we're almost done. Third step is to transpose. So what does it mean to transpose? It means you read the rows of your matrix and you write that as columns, or vice versa. Okay, so let me just say we switch rows and columns. So what do we get? Well, let's just read it horizontally and write it vertically. We read 3, 1, minus 2. 3, 1, minus 2. Then we read minus 3, 1, 1. Minus 3, 1, 1. Then 3, minus 4, 2. 3, minus 4, 2. Okay? That's pretty easy. And we're almost done. The last step, so what we get here is, this is the adjoint matrix. So the fourth and last step is to divide by the determinant of A. Okay? So here we have to compute the determinant, 2, 3, 3. So I should say determinant of A, okay? Not the determinant of this guy. So 2, 3, 3, 2, 4, 5, 1, 1, 2. Well, I'll let you check my computation. I found that it's equal to 3. Okay, so the final answer is that A inverse is 1/3 of the matrix we got there. 3, minus 3, 3, 1, 1, minus 4, minus 2, 1, 2. Okay, and now, so that tells us, remember, A told us how to find the u's in terms of the x's. This one tells us now how to find the x's in terms of the u's. If you multiply u1, u2, u3 by this, you get back x1, x2, x3. It also tells you how to solve the linear system, A times x equals something. Okay, that's the end for today.